Welcome to the Maths Made Easy tutorial on quadratic and harder graphs. So this is the second video on this topic. We'll be covering a couple more different types of graph that you need to be familiar with. The first of which is reciprocal graphs. So reciprocal graphs have the form y equals k over x. Now k can take any value. In the example we have here, we have the graph y equals 1 over x. So that's probably the most straightforward example. Now these graphs can be quite strange to get your head around, and that's because the graphs that they produce end up looking like two graphs. So why does this happen? Well, let's just consider some easy examples. So first of all, let's consider what happens when x equals 1. Well, if y equals 1 divided by x, then y equals 1 divided by 1, which is just 1. So as you can see, there is the point 1, 1 on the graph here. So if I mark on 1, you can see it a bit more clearly. But what happens if we have x equals minus 1? So I'll use green here just to differentiate. If we have y equals 1 over x, then it becomes y equals 1 divided by minus 1. Now, y divided by minus 1 is just minus 1. So as you can see, we also have the point minus 1, minus 1. So the implication is essentially that anytime you have a negative value of x, you end up with a negative value of y, and anytime you have a positive value of x, you end up with a positive value of y. So the graph is restricted to these two quadrants. That's in the top right here and in the bottom left here. In terms of the structure of the graphs, you should also be aware that these lines are asymptotes. So that means they get closer and closer to the axes but never actually touch. And that's because as you get closer and closer to 0, 1 divided by that value becomes increasingly large. But once you get to 0, the region is undefined. And the same as you get increasingly large, 1 divided by a much larger number just gets smaller and smaller, but it never becomes 0. So the final thing to point out is that this is the same regardless of the value of k. So it could be 2, it could be 3, it could be a million. The graph will generally have this sort of structure. So if we move on then to look at exponential graphs, this is the last type of graph we'll see in this video. Now these have the general form y equals k to the power x. So in this example, we have the graph of y equals 3 to the power x. So in terms of structural features of this graph, they're always going to have this kind of upwards curving shape, which is known as an exponential curve. And that's because as you increase the value of x, 3 to the power of that value becomes increasingly large at a faster and faster rate. That gives rise to this curve. The other thing to point out is that the value of y at x equals 1, so if I make a note of that there, you draw up, that is the value of k. So in this case that's 3, because k equals 3 in this graph. If you'd like to get some more practice with this topic, you can take our online exam. It's available through our revision platform. If you go to the test, you'll find loads of different questions, a variety of different question types, and you get instant feedback on each and every one of them. So if you're interested, then click the link below and it will take you straight there.